Hello everyone, welcome to Sangam Tutorials SP Gubi online classes for NCERT and Cbse 10th standard for mathematics and science. So in the last session we had proved Pythagoras theorem logically. It was a very important session. I hope you all enjoyed it. So in today's session we will be going with some very simple conceptual problems related to the Pythagoras theorem. So we all know that Pythagoras, using the axioms, postulates and the results of previous theorems, he has given us the theorem on right angle triangle, which is very famously called as Pythagoras theorem. But don't forget, the origin of this Pythagoras theorem is from Indian mathematicians, right? So with these words, so in a right angle triangle, the square on the hypotenuse is equal to sum of the squares on the other two sides. So this is Pythagoras theorem. So when we come for Pythagorean triplets, so it's a combination of three natural numbers. Please remember the definition. A Pythagorean triplet is a combination of three natural numbers where they satisfy Pythagoras theorem when applied to a right angle triangle. So it's natural because Pythagoras theorem is connected to a right angle triangle. So in today's session we will be solving very simple conceptual problems which may come in your examinations for 1 mark. Very important, very simple problems. Right, at last I have a very beautiful rider for you at the end of this session, where you are going to enjoy that rider. So it's also very beautiful. So we'll go with the today's problems. Sides of triangles are given. Okay, you have to imagine this. Some sides of triangles are given. For a right angle triangle, it's understood that. So determine which of them are right triangles. So using the sides, they have given 4 set of sides here. So using this, we have to determine which of them are right triangles. Right triangles, in the sense right angled triangles, both are one and the same. So in case of a right triangle, if you get a right angle triangle, write the length of the hypotenuse. So you have to recognize the hypotenuse. So very simple. Among the given 3 sides, if they form the Pythagorean triplets, if they satisfy Pythagoras theorem, then the natural number which is of the highest value or the biggest number, whatever you can take, which is the biggest number, will be the length of the hypotenuse, because in a right angle triangle, hypotenuse is the longest side when compared to the other 2 sides. But one thing we have to remember here, sum of any 2 sides of a triangle is always greater than the third side. We are not going with that issue now. Just in a right angle triangle I am speaking. In a right angle triangle, hypotenuse will be the longest when you compare that individually with each and every, it is the remaining 2 sides of the triangle individually, right? Okay. So here sides of a triangle are given. Okay, I am going to take the first problem. Determine which of them are right triangles. Okay, so in case of right triangle, if it is a right triangle, write the length of the hypotenuse. So we will go with the first problem here. So I will draw a right triangle. So this is the right angle triangle. So among the given values 7 centimeters, 24 centimeters and 25 centimeters, which is the longest side? So the longest side is 25 centimeter. I am going to put up for 25 centimeter there. I am not going to draw it as right angle triangle because still we have to check whether the triangle is right angled or not. So 24 and 7, you can give it wherever you want. So I will give it as 24 and give it as 7. I am not going to mention the triangle as a right angle triangle still, because still we have to prove that. Okay, let us check out. So we know that among the 3 sides, the longest side is the hypotenuse, and that is 25 centimeters. So 25 square I am going to take. So 25 square is 625. We know that. We will take 24 square plus 7 square. We are going to take it because the square on the hypotenuse is equal to sum of the squares on the other 2 sides according to the theorem. So 24 square is 576 plus 7 square is 49. So here 24 square plus 7 square will be equal to 6 plus 9, that is 15, 5, 7 plus 1 is 8, 8 plus 4 is 12, 1 carries, 5 plus 1 is 6. So 24 square plus 7 square is 625 and 25 square is 625. So therefore 25 square is equal to 24 square plus 7 square. So this satisfies Pythagoras theorem. That is, if you build a square on this side having side 25 squares and 25 centimeters, and if you build a square on this side having side 24 centimeters, and if you build a square on this side having side 7 centimeters, then the sum of the squares of these two sides will be equal to the square on the hypotenuse. That is, the square on the hypotenuse is equal to sum of the squares on other two sides. So that means it is a right angle triangle. It is a right angled triangle. Okay. So if it is a right angle triangle, he has the problem asks us to identify the length of the hypotenuse. So among the three numbers, what they have given us, the biggest number is 25 centimeters. So therefore, 25 centimeter is the hypotenuse. Right. So it's that simple. It is for 1 mark. Okay. Let us get into the second problem. 3 centimeters, 8 centimeters, and 6 centimeters. Okay, we will take a triangle. I am not going to mention that as a right angle triangle. Just we have to still see that. So 3, 8 and 6, that is 3 centimeters, 6 centimeters and 8 centimeters they are given. So take the biggest side, that is 8 centimeter, take a square of that. 8 square is 64, just leave it. Take the sum of the squares of other two sides, that is 3 square plus 6 square. That is 3 square is 9 plus 6 square is 36. So therefore 3 square plus 6 square is equal to 9 plus 36 is 45 we are getting, but 8 square here is 64, but some of the squares we are getting as 45. So therefore 8 square is not equal to 3 square plus 6 square. So therefore sum of the squares on other two sides, sum of the squares on other two sides is not equal to square on hypotenuse. Sum is not equal to hypotenuse, so therefore it is not a right angled triangle. So this is how we have to conclude. Very simple, right? So if it is a right angle triangle, conclude like this. If it is not a right angle triangle, conclude like this. I hope you got the idea. So this is the homework for you. Third problem and the fourth one of 3 sides which are given. Do it as a homework in the same manner. If it is a right angle triangle, this is enough. If it is not a right angle triangle, you have to write the reason for that and you have to conclude. Okay. So we'll go with the next problem. So before getting into the problems, just I want to speak with you regarding a small note you have to remember here. So consider this as a right angle triangle. Let us imagine this is triangle ABC where angle B is right angle. So therefore AC will be the hypotenuse because it is opposite to the right angle and these two are the remaining sides. So in this right angle triangle, the square which is built on the hypotenuse, is equal to sum of the squares on the other two sides. So this is the theorem, right? So that is AC into AC, it is going to become AC square, and this is AB into AB is AB square, and this is BC into BC is BC square. So we know that according to the theorem, so in triangle ABC, angle B is equal to 90 degrees. So therefore AC square will be always equal to BC square plus AB square. So AC square is equal to AB square plus BC square. So this is the root formula, that is the root of a right angle triangle when we directly apply Pythagoras theorem, that is AC square is equal to BC square plus AB square. So along with this, if you make BC square as the subject, then it becomes BC square is equal to, you can transpose AB square to here, that becomes AB square minus, AC square minus AB square. So this is also true. So here what it means is, if you want the area of this square BC square, that is if you want the area of the square which is built on BC, then subtract the area of that is AB square from AC square. So that is what has happened here, AC square minus AB square. So if you want the area individually to find out the area of the square on AB, then making AB square as the subject, so you can take it like this, AB square is equal to, transpose this BC square to LHS, so that becomes AC square minus BC square. So this is also true. So this is fundamental thing, and these two things which follow that. So all these three are nothing but Pythagoras theorem itself. So you can represent Pythagoras theorem either by this or this or this. All the three are true, right? So please keep this in your mind. This is very, very important for future problems. Okay, so we'll solve some very simple conceptual problems related to Pythagoras theorem. So first one, in triangle ABC, angle B is equal to 90 degrees, AB is equal to 5 centimeters, BC is equal to 12 centimeters. Find AC. Find AC. Very simple. So out of the three elements, that is AB in a right angle triangle, there will be three sides. So on all the three sides we have squares on it. So here they have given the sides of that is the length of two sides of the triangle, and you have been asked to find out the length of the remaining side. So we will apply Pythagoras theorem here. So Pythagoras theorem is particularly used to find out the remaining side. When two sides of a triangle are given, to find out the remaining side of the triangle, we use Pythagoras theorem, particularly in case of a right angled triangle. That is the use of Pythagoras theorem. So in triangle ABC angle B is equal to 90 degrees. Okay, so AB is equal to 5 centimeters, BC is 12 centimeters. Very good. So find AC. You have to find this. So this will be asked in your examination for 1 mark. So in triangle ABC, angle B is equal to 90 degrees. By applying Pythagoras theorem. By applying Pythagoras theorem, AC square is equal to AB square plus BC square. AB square plus BC square. So better is AC square is equal to AB square plus BC square. Very simple. So AC square is equal to AB square is, AB length is 5. So we will put 5. We have a square for that. So it's whole square plus BC is 12. We will put 12. Put a square for that. So AC square is equal to 5 square is 25 plus 12 square is 144. So AC square is equal to 25 plus 144 is 5 plus 4 is 9, 2 plus 4 is 6 and 1. So AC square, this is a perfect square, and 169 is also a perfect square. So we will take square root on both sides. That is square root of AC square is square root of 169. We will take only positive values for AC because AC is the length of a side. So always length or distance is always positive. So we will take, we will cancel. So AC is equal to 13 centimeters. So here the length of AC is 13 centimeters. So we get 13 here. So here these three natural numbers, that is 5, 12 and 13, they satisfy Pythagoras theorem. So here the combination of three natural numbers, that is 5, 12 and 13, forms Pythagorean triplets because they satisfy Pythagoras theorem. Right. So it's a simple one. We'll go with the next problem. Triangle ABC again, angle B is 90 degrees, AC is equal to 17 centimeters, AB is equal to 8 centimeters, and find BC. You have to find BC. So very simple problem. Okay. So in triangle ABC, let us take a right angle triangle. In triangle ABC, okay, angle B is 90 degrees, AC is 17, AC length is 17, that is the hypotenuse, AB is 8 centimeters, that is 8 centimeters, you have to find the length of BC. Okay, so out of the three elements, two are given and one being asked. So this is the purpose of Pythagoras theorem, right? So in triangle ABC, angle B is equal to 90 degrees. So by applying Pythagoras theorem, very simple. So AC square is equal to AB square plus BC square. Okay, AC square is 17, we have a square for that, is equal to AB square. AB is 8, so 8 whole square plus BC square. Now we have to find out BC, so therefore make BC as the subject. So BC square is equal to, send this 8 square to LHS, so that becomes 17 square minus 8 whole square. So BC square is equal to, it looks like some simple formula what you have learnt in your 8th standard class. So 17a square minus b square format, so this can be written as 17 plus 8 into 17 minus 8. So BC square is equal to a plus b into a minus b format. So 17 plus 8 is 27 minus 2, that is 25, into 17 minus 8 is 9. So BC square is equal to 9 5 it is 25 into 9, 4 times 125. 25 into 8 is 200. So 175 it becomes. So BC square is equal to 175. So take square root on both sides. Square root of BC square is equal to square root of 175. Square and root cancels. So BC is equal to, this 175 can be written as 25 into 9 again. 25 into 9 will do one thing. Very simple. Do not need these steps. Just will take square root over here. So square root of BC square is equal to square root of 25 into 9. So square and root cancels. So BC is equal to square root of 25 is 5 and square root of 9 is that is 3. So that becomes BC is equal to 5 3s, it is 15 centimeters. So the length of BC is 15 centimeters. So very simple problem. So the length of BC, it is 15. So here you should check out, when you get the answer, you should check out with the hypotenuse, because hypotenuse will be always the longest side. So longest side is 17 and the answer what you have got is 15, which is less than that. So your answer is right. So BC is 15 centimeters, right. We'll get into the next problem. Okay. A rectangular field is 40 meter long, and 30 meters broad. 30 meters broad. Okay. Find length of its diagonal. Find length of its diagonal. Right. Very simple problem. So it is application. The rectangular field is 40 meters long and 30 meters broad. So let us get into the problem. So this is the rectangular field. Right. So the rectangular field, take it as ABCD. If you have a field which is in the shape of a rectangle, so it is 40 meters long. So it is 40 meters here. So it is 40 meters here, and 30 meters broad. So this is 30 meters broad, and this is 30 meters. Because in a rectangle, opposite sides are equal. So find the length of its diagonal. So we will draw one of the diagonal here. So BD is the diagonal. So you have to find the length of this diagonal. So we know that in a rectangle, all the four angles are equal to 90 degrees. So therefore we will take this as 90, this as 90. Here also it is 90. This is also 90. Okay. So now we will select any one of the triangles, either this or this. So we will go with this triangle, in triangle BCD. So in triangle BCD, angle C is equal to 90 degrees. So by applying Pythagoras Theorem, right, very simple, because in this triangle BCD, we know the length of two sides, we have to find out the length of the other side, that is hypotenuse. So here in this triangle, if you find out the length of the hypotenuse, it is nothing but you are finding the length of the diagonal of this rectangle. Okay. So opposite to 90 degrees is BD square. So BD square is equal to BC square plus DC square. Right. So BD square we have to find out. BD square is equal to BC is 30 whole square plus DC is 40. So it becomes 40 whole square. So BD square is equal to 30 square is 900 plus 40 square is 1600. So BD square is 2500. So we will take square root on both sides. BD square is equal to square root of 2500. So square and root cancels. So BD is equal to, so square root of 2500, that is square root of 25 is 5, and for two zeros we get 1 0. So that is 50 meters. The length of BD is 50 meters. So therefore you have to write the conclusion, because it's a statement problem. So therefore length of diagonal of rectangle is 50 meters. Right. So this is for maybe 2 marks or 1 mark in 1 mark questions in multiple choice. Right. So it's a very simple problem. Right. We'll go with the next problem. Right, another application. I hope this is the 5th problem, right? So a ladder 17 meters long, reaches the window of building 15 meters above the ground. 15 meters above the ground. Find distance of foot of ladder from building. Alright. So it's an application problem. You have to apply the knowledge of Pythagoras theorem to find out the value of the distance of the foot of ladder from the building, right? So a ladder 17 meters long reaches the window of a building. For example, let us take this as the building. So building is always perpendicular to the ground, right? So I hope maybe let us take this as the window. A ladder 17 meters long reaches the window of a building. So this is the window. So this will be the ladder. For example, we will take this will be the ladder. So this is the ladder, right? So this is the ladder. It reaches the window of a building 17 meters above the ground. So this distance is 17 meters. Let it be 17 meters. A ladder 17 meters long. Sorry, ladder is 17 meters long. Ladder is 17 meters long. Okay. This is ladder is 17 meters long. A ladder 17 meters long reaches the window of a building 15 meters above the ground. Okay. So the window is 15 meters above the ground. So this is 15 meters, right? Find the distance of the foot of the ladder from the building. So this is the foot of the ladder. This is the building. So you have to find the distance between the foot of the ladder and the building. So this distance we have to find out. So as we have drawn our own diagram, so we have to give a name for this. So let the window be at a point A, let this be B, and let this point be C. Right. So when you look at the figure, you get a triangle, that is a right angle triangle with angle B is equal to 90 degrees. So in triangle ABC, angle B is equal to 90 degrees. So by applying Pythagoras theorem, very simple. Opposite to the right angle is the ladder, which is the hypotenuse. So therefore AC square is equal to the window from the ground, which is AB, which is equal to 15 meters, that is AB square, plus this one distance, that is BC square. So AC square is 17, so 17 whole square is equal to AB is 15 whole square, plus you have to find the length of BC square. So here you can go with this. BC square is equal to, transpose this to LHS, so that becomes 17 square minus 15 square. So BC square is equal to A square minus B square format. So 17 plus 15 into 17 minus 15. Okay. So I hope you can go with the next procedure. So simplify this, cancel the square root of the square of BC square by taking square root on both sides. Maybe you are going to get a perfect square. Solve it and write the answer in the form of a statement. Right? So this is the homework. Please continue the problem. Right? Okay, we'll go with the next problem. In an equilateral triangle, of side A units, side A units. Prove that one altitude is equal to a root 3 by 2, and the second one area is equal to root 3 into a square by 4. Very important problem. Here the result of this problem you are going to use it in many different other problems. So this problem is very important. You should know how you get the altitude of an equilateral triangle, and also you should know how to get the area of an equilateral triangle. So I hope you have done this in your 9th standard class, maybe in coordinate geometry problems, that is in Heron's formula problems. You have applied this area and the altitude. So this is in today's class you are going to learn how you are going to get this. That's very important. So we will get to the solution. In an equilateral triangle of side A units, so this is an equilateral triangle of side A units. So let us take it as triangle ABC. So each and every side is A units. So this is A units. A represents some number. Okay. So this is A units. Alpha numeral. A is an alpha numeral because it represents some number. Okay. So side is A units, and prove that altitude is a root 3 by 2. So let us draw the altitude perpendicular. So call it as D. So this is the altitude. So we have to prove that the length of AD, that is altitude, is a root 3 by 2. A root 3 by 2 units. So it's very simple. So here triangle ABC is equilateral. Triangle ABC is equilateral in the sense all the three sides are equal. Okay. Then here AB is equal to BC is equal to AB is equal to BC is equal to AC is equal to A units. It is given. It is A units. Now, when we draw an altitude for an equilateral triangle, it will be drawn to the midpoint of the base of the triangle. So when we draw an altitude for an equilateral triangle, it bisects the base, or it touches the midpoint of the base of the triangle. So here BD will be equal to DC. BD length will be equal to DC. So if BC is A units, then BD will be half of BC, that is A by 2 units, and DC will also be A by 2 units. So BD is, alright, AD is the altitude, AD is the altitude, so therefore BD is half of, that is BC. So BD is equal to half into A is equal to A by 2. So the length of BD is A by 2, and we have AB as A, and we have to find out AD. So now in triangle ADB, we can take this triangle. So in triangle ADB, angle D is equal to 90 degrees. So by applying Pythagoras theorem, so this is the right angle, opposite to that is AB, so that is AB square is equal to AD square plus BD square, AD square plus BD square. So here AB square is, AB is A, so therefore it becomes A whole square is equal to AD, we have to find it out, so AD square plus BD is A by 2, so that becomes A by 2 whole square, right? So A whole square is A square is equal to AD square plus, this square applies for the numerator as well as the denominator, so therefore it becomes A square by 4, that is 2 square is 4. So keeping AD square as the subject, we will transpose A square by 4 to the LHS. That becomes A square minus A square by 4 is equal to AD square. So A square, below that in the denominator we have 1 here. So for 1 and 4 LCM is 4. So A square by 1 into 4 is 4A square minus A square by 4 into 4 is A square is equal to AD square. So therefore AD square is equal to 4A square minus A square is 3A square by 4. So let us take square root on both sides. That is AD square root of AD square is equal to square root of 3A square by 4. Square and root cancels. So we are left over with AD is equal to. So among the three elements, A square is a perfect square, 4 is a perfect square. So when they, okay, or you can do like this, square root of 3A square by square root of 4, you can split this. So AD is equal to, for A square is a perfect square, as it comes out of the square root it becomes A root 3, because 3 is not a perfect square, it remains inside the square root, by square root of 4 is 2. So therefore AD is equal to A root 3 by 2. So that is what is to be proved. So then we will go with area, that is the second question here. So now in triangle ABC, it's an equilateral triangle here. So in triangle ABC, area of triangle ABC is equal to half into base into height. That is base into height. Just now we have proved that height is A root 3 by 2. Height is A root 3 by 2. So half into base is BC into height is AD. So it is equal to half into BC. The entire length of BC is A. So half into A into AD. AD just now we have proved that it is A root 3 by 2. So it becomes A root 3 by 2. So below A we have 1. So multiply all the numerators and multiply all the denominators. So 1 into A root 3 is A square root 3 by 2 into 1 into 2 is 4. So therefore area of an equilateral triangle is A square root 3 by 4 or root 3 A square by 4. Anything you can do it. So this is how it comes. It is very important. You have to practice this, and also very important thing is you have to remember the values. That is, in an equilateral triangle the altitude is always A root 3 by 2, where A is the side of the equilateral triangle, and the area of an equilateral triangle is always A square into root 3 by 4, where A is the side of the equilateral triangle. You have to remember this. So let us conclude this session by this problem. So in tomorrow's session you are going to come across still more very important questions, including riders and numericals. More you can see more number of riders and more number of entities on right angle triangles. Very less numericals are there in this. So including that, after riders and entities, at last I am going to again take up more number of application problems where you are going to apply the right angle triangle property in your daily life, right? So I hope you enjoyed the entire session. Practice all the problems. Don't ignore, because practice will make you very perfect in mathematics. Write the test which is given at the weekend. Don't miss the test and examinations. So please subscribe the channel and put a like button on it. So until that, stay home, stay safe, and keep learning.